Okay, so in this video we're going to take a look at some other kinds of arrays that we can create besides just int arrays. So for this one, by the end of this, we're going to go into not just primitive data types, but also take a look at a couple of different kinds of classes that we can make arrays out of. So when I create this new file, or if you create a new project for this, we're going to go ahead and call this object arrays. Okay. So we're going to go ahead and make a class header. We're going to have our main method. And just very briefly, we'll go through a couple of them. So we'll first look at primitive data types. So a couple of standard ones, we might have a double array. We could call this something like decimal numbers. So in this case now, instead of just having whole numbers like we did for our int array, we could actually include some numbers with decimals in them. So you could do something like 5.3, 3.6, 4.7, something like that. So this shows a double array. We could also have maybe an array of characters. So we'd have a char array. So you have something like this. We can call it characters. This is going to be equal to an array where each individual item needs to have single quotes around it. So we could have like maybe the letters of the alphabet. So we could have like A, we have B, we could have C. One thing to keep in mind if you're doing this, pay attention to the fact that the single quotes only go around to the individual items. When we have these commas that we use to separate the items, we don't want to put that comma inside of the single quotes. Otherwise, then this will start to cause an error. Okay. One of the other things to note about this array of characters, in just kind of an additional aside about this, in some languages, say like various C languages, a character array is actually another way to describe a string. In Java, there's a little bit more of a distinction between the two, but you can kind of see the relationship between these two, or why it is that this comparison is possible, because of the fact that if you think about a string, it is really nothing more than a sequence or an array of individual characters. So just a general idea about kind of the connection between those two things. In addition to this, we might also have something like, say, a Boolean array. For a Boolean array, typically the reason you might see something like this is if you need to keep track of a bunch of different sort of true-false, maybe like yes and no selections or choices that the user would make. That would be a good purpose for a Boolean array. So I'll go ahead and call this something like choices. And for this one, you're just going to specify those individual true-false values, again with the comma separation. So you could have something like true, maybe true again, and then false. So this would give you a Boolean array. Okay. In addition to the primitive data types, we can also do this for different kinds of classes. One of the most common ones that is available to us by default would be the string class. So we could make a string array, something kind of like this. And generally the reason we do this, maybe you want to use this for something like a set of words or a set of names. So we do this for a set of names. We could do something like, let's say we have David. Make sure that we actually do this with double quotes. Megan and say Mike. Okay. And if we do this, we can go ahead and create these individual strings all put together in a single collection within this array. So if we wanted to, we could access one of these. We can do a print statement here. So we'll print out names 0. This will give us David. So we'll go ahead and compile this. And then run it. And then we can print out David to the console. In addition to being able to access the individual strings inside of this array, we can also use methods on each of them. Considering the fact that what we're getting out of this is a string, we can still apply string methods to it. So maybe, for example, we want to go ahead and take this David that we're getting, and we want to just capitalize the entire thing. So we can use the toUpperCase method on name 0 on this David string that we're getting. So go ahead and save that. We'll compile this and run it again. And now we can see David in all caps right here. Okay. So this gives you a general idea about being able to use string arrays. One of the things to keep in mind if we're doing this with a class like this, in a more abstract sense, keep in mind that unlike what we did up here, where we're creating this array, and if we navigate to the array, that location somewhere in memory, we would find each one of these values being stored inside of it. But in this case, because we're dealing with a class inside of this array, each one of these individual things we're putting into it, if we were to navigate to where the array itself is located in memory, we would find that the items at each one of those positions at the array itself would just be a reference to the string. So each one of these 3 strings would then be somewhere else in memory. So maybe we'll go ahead and take a look at this conceptually, just very quickly. So we would have our array right here. So I'll go ahead and show the array vertically so that everything fits properly. So we'd have our 3 items for this array. And for each one of these items, we would then find a reference to a string that is going to be located somewhere else in memory. And hopefully you can bear with the noise. Seems that somebody's moving. So we'll have these references that point to some other location in memory, and then at each one of these locations, this is where we're going to find each one of those strings. So make this a little bit larger. This is where we'd find our David, our Megan, and our Mike. Okay, so conceptually, this is essentially what we're expecting in memory when it comes to creating an array of some class type, like a string. In addition to being able to do this for a string, we can also do this for any of the custom classes that we make. So maybe if we come back over to our code, in addition to creating these couple of primitive types and the string type, maybe we want to make one for our own custom class. So let's go ahead and include an additional file for this. And this additional file is actually going to be the rectangle class, something we've made in a previous chapter. So go ahead and do rectangle.java. Go ahead and save that. So you make sure that if you're doing this in an IDE, that you save this in the same package as the object arrays, since we are going to be using this in that file as well. So we'll have our public class rectangle. So for this one, I want to go ahead and create my 2 fields. So we're going to have a private double for the length. We'll start this off at 0. And a private double for the width, also starting off at 0. For this one, I'm just going to create enough to be able to set up just a couple of things. So I'm just going to use, let's say, just a single constructor, and then 2 setters for each of the fields and 2 getters for each of the fields. So we're going to have our public rectangle. So let's say that we use a no-args constructor for this. So we can just go ahead and set the length and width to 1. We'll then also go ahead and create our setters. We're going to have a public void set length. We're going to pass in a double new length. And this is going to be the length field is equal to the value of new length that got passed in. We'll also do this for the width, so public void set width, double new width. So width field is equal to new width. And then we'll also include 2 getters so that we can go ahead and return each of these values. We're going to have a public double get length. We'll go ahead and return the length. And we'll have public double get width, and we will return the width. Okay. So then we can go ahead and come back over to our object arrays, and then we can go ahead and actually make this. So the way that I want to make this, I'm going to do this a little bit differently from what I did right here with each of these. So we'll go ahead and show it with the rest of the body of this main method. So I'm going to go ahead and create my rectangle array. So we're going to specify the name of the class, which is rectangle, and then we have that pair of brackets to indicate that this is going to be an array of rectangles, and then I'm just going to call this rex. Okay. I'm then going to say that this is equal to a new rectangle array, and I want to give it this one a size of, let's say, 3. Okay. The next thing I'm going to go ahead and do is start assigning something to each one of the locations of this array. So I'm going to do rex at position 0, and for this I'm going to say this is equal to a new rectangle. So we're going to go ahead and put a new rectangle object into position 0 of this rex array, and then I'll go ahead and do the same thing for the other positions as well. So rex 1 will have a new rectangle, and rex 2 will have a new rectangle. Okay. So at this point now, if we think about what this looks like in our conceptual construction of it, go ahead and remove what I've got here and just remake this. So again, we'll show the array vertically so that everything fits properly. We're then going to have our references to each one of these locations. So at each one of these locations, what we're going to find is going to be a rectangle object which consists of 2 pieces of data. Okay, so right now, because we haven't really done anything with them, it seems they have a lot of stuff to move. So for each one of these, we're going to have 2 pieces of data. We're going to have a length and a width. So we're going to say something like length is equal to 1.0 and width is equal to 1.0. I'll go ahead and place that right here, and we'll do that for each one of these. Okay, so we've got our 3 different rectangle objects that we've constructed here at each one of these different locations in this array. Okay, and then if we navigate to each one of those locations, we're going to find the data for that, in addition to some way to be able to call or utilize the methods of it. But the primary thing that we're concerned with is going to be the data at that location. Okay. So coming back over here, so the next thing I want to be able to do, in addition to constructing these, I also want to go ahead and just print out one of these and also demonstrate something similar to what we did for our strings up here, where I can actually utilize some of the methods. So we'll do system.out.println. So we'll go ahead and grab the rectangle at position 0. And I want to go ahead and get one of these values. So let's say we want to get the length of it. Okay. So this will be our way of saying that we want to grab this particular rectangle right here that we constructed, and precisely I want to get the length of that rectangle. So we're going to go ahead and see the 1.0, since that's what all of them have been initialized to. So compile this, we'll run it. So we still got our David in all caps from our previous example, and we've got 1.0 for the length of that rectangle. Okay. And then the other thing I'll go ahead and do is also test out one of these setter methods. So we'll do that on rect0. Since we're already getting the length of that one, we'll go ahead and set the length. And let's say we want to change the length of this to something like 5.5. So we'll go ahead and save that. So we're going to now change this rect0. We're going to set its length to 5.5. And then we're going to go ahead and print that value to the console. So we'll come over here and compile this. We'll run it, and now we can see the value 5.5. Okay, so this is just a quick demonstration of being able to use arrays to create these sort of collections of objects, and then also being able to access or use the methods for each one of these objects on a particular position somewhere in these arrays. Okay. Going into the next set of videos, we're going to start looking at a slightly more complex concept with arrays, which is going to be dealing with just a few very sort of fundamental searching and sorting algorithms.